Hey guys, I'm just going to work out some problems for the review. These are the problems I'm going to work out. I'm going to work out 15 twice, but I'll just go through them. Kala is here with me, so if she barks or whines, then that's probably what you're hearing is my dog going crazy. Okay, so on number 15, I'm actually going to work it two different ways because some of you worked it. Some of you think of it one way and some of you think it the other. Okay, so the first thing because I saw it, I went ahead and simplified 64 and 16. 64 divided by 16 is 4. And then the negative, anytime you're taking an odd root of a negative, just make it positive and put a negative on the outside. Okay. As far as x's goes, because there's a cubed root on top and a cubed root on the bottom, it's for the same reason I can simplify these. I can simplify those. Cubed root of x over the cubed root of y is the same thing as, or the square root in this case, the square root of x over y. Okay. So I've got 7 of these and then 6, so I'm going to cancel out the 6 of them, leave me with only 1 on the top. Cancel out 4 of these, leave me with only 4 on the bottom. And I'm going to cancel out 2 of those, leave me with only 4 on the top. So here's what I've got so far. The negative cubed root of 4, x to the first, no y's, and z to the fourth. And then I've got the cubed root of y to the fourth, and that's it in the denominator. Now, before I start trying to rationalize by multiplying the cubed root on top and bottom, I want to simplify these variables. 3 does not go into 1, so I can't simplify that, but 3 does go into 4 once, so I put a z on the outside, and I have 1 left over. 3 also goes into 4 here once, 1 on the outside, and then 1 left over. So I'm actually dealing with negative z times the cubed root of 4xz over y times the cubed root of y. Well, in order to rationalize, you don't want to have a root in the denominator. So what we need to do is you need to multiply by the cubed root of y to get rid of it. Well, just like the square root times the square root is, so like the square root of 5 times the square root of 5, it's the same thing as square root of 5 squared. They cancel each other out, you're left with 5. Well, if you've got the cubed root of x times the cubed root of x, that doesn't cancel each other out. You need another cubed root of x, so that it's the cubed root of x cubed, and that's when you get the number. So we need to multiply by the cubed root of y twice, or the same thing as multiplying by the cubed root of y squared. Okay? So these three, it's not like they just go away. They just equal y, which I've already got another y. So my denominator is now y squared. Okay? Well, when I multiply in my numerator, I've got a negative z, and then I've got a cubed root of these two multiplied by each other, because when you're multiplying two roots of the same base, you can multiply their insides. Okay, so I've got 4x y squared z. 4x y squared z. None of these powers are larger than 3 or equal to 3, so I'm done. There's your answer. Now, if you had not simplified, because you might not see that 64 divided by 16 is 4. Well, then you would go ahead and take the cubed root. You know the cubed root of negative 64 is, well, let's see, power of 4 to the third is 64, so the cubed root of 64 is 4. So you might say, well, that's negative 4, and hopefully you would simplify with the numerator and the denominator. The x's and the y's the same, and the z's the same way that we did before. So 1, none, none, 4, none, and 4. So maybe you would be thinking this, the cubed root of negative 4, the cubed root of x, and then z to the fourth, over, well, down here, I don't have a cubed root of 16, but I do have a cubed root of 8. So I could say the cubed root of 8 is 2, so I put 2 on the outside, and then that 2 stays on the inside. And I'm left with 4 y's. Well, just like before, I would want to simplify the z and the y with their powers. So this right here, 3 goes into 4 once with 1 remaining. 3 goes into 4 once with 1 remaining. Okay, so you'd end up with negative 4z times the cubed root of xz over 2y times the cubed root of 2y. Okay, well, you could go ahead and simplify the 4 and the 2 if you wanted to. 4 divided by 2 is 2. And then you'd need to multiply by the cubed root of 2y. So I've got the cubed root of 2y and the cubed root of 2y. I need 2 of them because I need 3 out total. And the cubed root of 2y and the cubed root of 2y. Okay, so I've got, did I forget a number up there? No. Wait 1 second, let me look at this. I have a 2 in the denominator. Oh. And 4 in the denominator. Oh, duh. Okay, good. Sorry, I went blank there for a second. Okay, so, I was wondering how I got no numbers up there, and I was going to have numbers, but they're going to cancel out, so it doesn't matter. Okay, so the numerator is a negative 2z times the cubed root of, well, I've got xz times 2y times 2y. That's a 4x y squared z. So 2 times 2 is 4x y squared, and then z. Over, I've got y times, remember, the cubed root of 2y times itself 3 times is just 2y. So I've got a 2y times a y, which is a 2y cubed, sorry, 2y squared, because it's y times y. 2's cancel out, and then I've got the same answer that I had up there. Okay, good. All right. Now let's go to 16. Okay, same deal. Different problem. The 5 and the 4 don't simplify, which actually makes it a little bit easier, so we'll go ahead and just start simplifying the variables. 6 of these with, and leave me with 5 up there. 6 of those leave me with 2 down here. 2 of these leave me with 10 up there. Okay, so I've got the 4th root of 5x to the 5th, z to the 10th, over the 4th root of 4y to the 2nd. Okay. 4 goes into 5 once, with 1 remaining. 4 goes into 10 twice, with 2 remaining. And then 4 doesn't go into y squared. So I've got xy squared times the 4th root of 5x z. Why did I do y? That's a z. Okay, so z squared. G. Okay, and I'm going to do z squared on the inside. And then I've got the 4th root of 4y squared. Okay, so it's the 4th root, meaning I need 4 of them to cancel each other out. So I'm going to multiply by the 4th root of 4y squared 3 more times. Now I could write it out 3 times, meaning my denominator is 4y squared, or I could multiply it by the 4th root of 3 4s, and then y squared times y squared times y squared is y to the 6th. Now the only reason I'm not multiplying out 4 times 4 times 4 is because it doesn't help me necessarily. I'd rather deal with the 2's that you get when you break down the 4's. So I'm going to go ahead and write this down so it's a little bit easier to do the next step. I've got xz squared. I've got the 4th root of 5 times 4 times 4 times 4 x y to the 6 z squared. Okay, so I need to simplify the 4's and the fact that I have power inside the root that's bigger than the root. Okay, 4 is 2 times 2 times 2 times 2 times 2 times 2. So there's those 2, and those 2. Well, that's 6 2's. Well, that's the same thing as saying 2 to the 6th, which is the same thing as saying 2 to the 4th times 2 to the 2nd. What I'm trying to get at is 4 of these can be taken out because the 4th root of 2 to the 4th is 2. So I have a 2 on the outside, leaving me with a 2 squared on the inside, which is a 4. Okay? Or I could have just seen it as those 2 right there, but that's fine. Okay, so those are gone, and they're up here. So I've got a 4 left over on the inside. I should have just knocked out 2 of them. Whatever. And then 4 goes into 6 once. So I've got a y on the outside. And I have 2 remaining on the inside. So I've got a 2xyz squared, 2xyz squared, times the 4th root of 5 times the 4 left over, the 2 2's, 20xy squared z squared, over 4y squared. It's not my final answer yet because I need to simplify with this right here. I've got a 2 and a 4, which makes that a 2. I've got 1y and 2y, so I just got 1y. So I've got x z squared and then that divided by 2y, and there's your answer. Okay, let's do 23. 23, I want to cancel out one of these x's with one of those, leave me with 2 on top, and then 4 of these with 4 of those, leave me with 1. So I've got the square root of x squared over 6y, the square root of that. The square root of x squared is just x over the square root of 6y. I don't want to square root in the denominator, so I multiply by the square root of 6y on top and bottom. That is 6y, so I've got x squared root of 6y over 6y. And that's that. Okay, let's do 24. 24 has 12 and 18. You could see it as 4 times 3 and 9 times 2. I'm going to go ahead and simplify. Might be easier. 4 times 3 and 9 times 2 is your 2 and 3 on the inside. Okay, if you simplify the 12 and the 18, yeah, that's fine. You get the same thing. I'll just do that. 12 and 18 both divide by 6 twice and 3 times. Okay, so I've got a 2/3, and then I've got 2 of those canceling out with 2 of those, leave me with 3. 5 of those canceling out with 5 of those, leave me with 4, and 2 of those canceling out with 2 of those, leave me 2. So I've got the square root of 2x cubed y to the 4th over the square root of 3z squared. Okay, it's the square root, so 2 goes into 3 once with 1 remaining. 2 goes into 4 twice with none remaining. And once with none remaining. So I've got xy squared times the square root of 2x over z times the square root of 3. I need to multiply by the square root of 3 on top and bottom to get rid of the square root to rationalize. That's just a 3. So I've got xy squared times the square root of 6x over 3z. And there's your answer on 24. Okay. Now let's do 41 and 42, and we'll be done. Okay, some of you approach it different ways, and it's completely fine however which way. I might do it once and then do it another way, just to kind of break it up. I'll go ahead and write it down twice. Don't forget that when you're multiplying things, you can distribute a power. And they're all being raised to the negative 2. And when I multiply, when I say x to the 4th times x to the 5th, I add. When I say x to the 4th divided by x to the 5th, I subtract. Sorry. And when I say x to the 4th to the 5th, that's when you multiply. Okay? So that's x to the 9th. That's 1 over x to the 1st, or x to the negative 1. And then this is x to the 20th. So just remember your properties. Okay. So one option is to just go ahead and take it slowly and simplify everything as you go. So I'm going to go ahead and just work with this first. I've got x to the, when I distribute this power of 3 to both of these, I've got x to the negative 6 and y to the 9th times z to the negative 1st. Okay, so that's that. Now I want to distribute over x to the 5th, y to the negative 2, z to the 4th. I want to distribute my power of negative 2. So I take it piece by piece, and remember I have to distribute it to everything, because this is for the same reason that x over y to the 3rd is the same thing as x cubed over y cubed. I have to distribute the power to both the top and the bottom. So x to the positive 12th, y to the negative 18th, z to the negative 2. Now you may have gone this route first, and then you start to decide, well, if I know where it goes, shouldn't I put it there? If it's y to the negative 18, it goes in the denominator. And I agree, but it's just whatever. So x to the negative 10th, y to the 4th, and z to the negative 8th. Okay, so anything that has a negative power belongs on the opposite. So if it's in the numerator, it belongs in the denominator, and vice versa. So this actually belongs up here with the 12, so that's really just x to the 12th times x to the 10th, which is x to the 12th. Plus 10, so x to the 22nd. This really belongs down here, y to the 18th, so that's 18 plus 4, which is again 22. And these switch, so I've got 8 and 2 on the bottom, meaning I've got 6 left on top. And there you go. Which is not what I had answer sheet, but I think we talked about that. Okay, the other option is just do it all at one time. If I've got x to the negative second to the third, that's x to the negative 6 times negative 2 is x to the 12th. Okay, y to the third is y to the ninth to the negative 2. So y to the ninth to the negative 2 is y to the negative 18th, which really just belongs in the bottom, y to the 18th. Z to the negative first to the negative second is just z to the second, and that belongs on top. Okay, x to the fifth to the negative second is x to the negative 10th, so if that's in the denominator, belongs on the top. Y to the negative second to the negative second is y to the negative, or positive 4, so it belongs in the bottom. And z to the 4 to the negative 2 is z to the negative 8. If it was in the bottom, now it belongs on the top. Wait 1 second, what did I do? Did I mess that up here? Oh, shoot. No, here, correct me. That was a negative, which meant that was a positive 2, which meant that's a positive 10. Okay, alright. So we just add 8 and get 10. Okay, whoops. Alright, and yeah, okay, so x to the 22nd, z to the 10th, and y to the 22nd. There you go. Okay, that was fun. Let's do 42. On 42, I'm going to just go ahead and start rewriting things as I see them. So I've got 2a to the 4th. Now, when I multiply, just as a reminder, 2/3 times 4. 4 is the same thing as 4 over 1. You multiply across. That's 8 over 3. So in the same way, this is over 1. I multiply all of these times all of those over that. I think you saw that because my hand was in the way. But I'm going to go ahead and just put it all, I mean, you might as well put it over one fraction. It doesn't really matter. It's the same thing. 2a to the 4th, b to the negative second means b squared on bottom. Now this is 3 to the negative second. Now you have to remember what that means. That means 3 squared in the denominator. Okay, so you could think of it as, let's put 3c to the third to the second in the denominator because it's got a negative power. Okay, so then we take it piece by piece. Now I don't have anything in the numerator, and so this 6 is the first thing I come across, that stays in the bottom. The a to the 5th is a positive power, that stays in the bottom, but b to the negative 8th, that goes to the top as b to the positive 8. 3 squared is 9, and then c cubed squared is c to the 3 times 2, which is 6. So I've got 6 times 9, I'll go ahead and simplify the 2 and the 6 though. 2/6 is 1/3. 3 times 9 is 27. I've got 5 a's on bottom, 4 on top, so I've got 1 on bottom. I've got 2 b's and then 8, so 6 on top. And then I've got 6 c's on bottom, and there's your answer. Okay. I'm going to sally out that I'm done with this, but please just sally me if there's another problem that you have a question with, and maybe I can help you, okay?